Welcome back to PV Online. Today we're going to take a look at the difference between weight and mass. Weight is a force. It is a force due to gravity. That means the unit for weight is going to be a Newton. Mass is the amount of matter. That's how much stuff is present. The unit for mass is going to be a kilogram. So weight and mass are not the same. So let's just take a quick look at this example of this problem. So we have a 66 kilogram astronaut. So I know from the unit that the mass of my astronaut is 66 kilograms. And so the question is find the mass and find the weight of the astronaut. And we're going to do it at 3 different places. We're going to do it first on Earth. Second, we're going to do it on the moon. And last but not least, we're going to do it on the space shuttle. Okay, so let's take a look at this. If the mass, or the amount of matter, is 66 kilograms, on Earth, his mass is going to be 66 kilograms. But now we want to find the weight. Well, so the weight is going to be the mass times the acceleration due to gravity. And on Earth, what is the acceleration due to gravity? And it is 9.8. So we're going to take 66 times 9.8. We get the weight on Earth is going to be 647 newtons. All right, let's do it on the moon. How much mass does my astronaut have? How much matter is present? Well, he hasn't gone on a diet, so his mass is still 66 kilograms. But what about gravity? Is gravity going to be the same on the moon? And the answer is no. It's going to be much less, and that's why when you see images or video of astronauts walking on the moon, they move so differently because gravity is so much smaller. The acceleration of gravity on the moon is about 1/6 of what it is on Earth. So g on the moon is 1.67 meters per second squared. And the reason for that is your force due to gravity is dependent on the mass and the distance to the center of the planet. So the fact that the mass of the moon is so much less than the mass of the Earth is why its g is much smaller. So now if you were to stand on a bathroom scale on the moon, this astronaut would only weigh 110 newtons. So let's take a look at our final example. In our final example, we're on the space shuttle. Well, the amount of matter, the astronaut's still there. The amount of stuff is still 66 kilograms. But here we're going to give what we call apparent weightlessness. And what that means is our gravity is basically going to be 0. If you were going to take 66 times 0 and he was still going to try to stand on a scale, he would weigh 0 newtons. Okay, that would give the appearance of being weightless. So remember, weight changes depending on where you are. Mass doesn't. The amount of matter is going to stay the same. All right, we'll see you next time.